Good morning, viewers. My name is Revati Rangachari, and I am the Technical Account Manager for MySQL, managing some of the large customers in India that uses MySQL Server as their core database. Today, I'm going to demonstrate on MySQL Innodb Cluster on how to install and configure a Innodb cluster and also test it with the Java application. Some of the Innodb cluster features like the fault tolerance and the automatic failover. What you see in front of you is the MySQL Innodb cluster architecture diagram. MySQL IC, that's Innodb cluster, provides high availability solution for MySQL. MySQL shell includes admin API, which enables you to easily configure and administer a group of at least 3 MySQL server instances to function as Innodb cluster. Now, each MySQL server instance runs MySQL group replication, which provides the mechanism to replicate data within Innodb cluster with built-in failover. Now that we understand we need 3 MySQL server, let me go back to my server instances. What you see here are 4 servers that are coming from the Oracle Cloud Compute instances. The top one, I am going to use it as a kind of application server where I will be running my Java application to test the Innodb cluster failover mechanism through a simple Java application program, which I will be explaining when we begin with the testing. But to start with, we need to get the MySQL servers ready first. So I have already installed MySQL server in WS2 and WS3 to save time. But for the sake of demonstration, I am going to install the MySQL server in the WS1. Let me go back to my folder where I have the MySQL binaries. So if I say LL here, I should be seeing all the MySQL binaries that is required for the RPM installation. That's what I'm going to do today. That's a RPM installation. So let me go back and check whether I have the command in the history. So before I start doing the install, um, it's better, always a better practice to stop the server if service is already running, so that we get a fresh installation of the MySQL server. So this is the install command, RPM install command. I'm going to run that now, and while the server is installing, let's go back and look at the architecture once again. So admin API here removes the need to work directly with the group replication in an Innodb cluster. MySQL router automatically configures itself based on the cluster you deploy, connecting client applications transparently to the server instances. In the event of an unexpected failure of a server instance, the cluster reconfigures automatically. In the default single primary mode, IC or the Innodb cluster has a single read-write server instance that is called the primary. Multiple secondary server instances are replicas of the primary. If the primary fails, a secondary is automatically promoted to the role of the primary MySQL. Router detects this and forwards client applications to the new primary. Advanced users can also configure a cluster to have multiple primaries. Now let's go back to the instance and see whether MySQL is installed properly, the RPM is installed properly. I'm going to take help from my notepad to check whether I am executing all the commands in sequence and that I don't miss anything. So we saw that the Innodb cluster is created using the admin API, that is the MySQL shell. So let me also install the shell in the WS1 server. And remember, I have already done these in the WS2 and WS3. And in WS1, I'm just doing it for the sake of demonstrating how easy and quick it is to install the MySQL server. There I'm checking whether my RPM is installed properly, and then I'm going to start the MySQL server so that we can start using it to create Innodb cluster. While that is starting, this command is to check whether MySQL is running as a daemon in this server. So you see user has been MySQL D is the daemon that is starting the MySQL server. Now, when the MySQL server gets installed, it creates a default username that is root and a password which gets recorded in the MySQL error log file that is called the MySQL D log, which by default gets stored in the where log folder. And you may be aware that the MySQL default directory is /where/lib. So I am trying to access the server. There is error here. Let me check whether server is running. Yes, it's running. So let me copy and paste the command or the password. Okay, copy and paste. Okay, I'm inside the server now, and if you execute any command inside the client, it does not allow you to do anything unless you change the default password of the MySQL server. So let me go back and see whether I can change the password using the alter user command. And now I'm going to create an admin user to be used as part of the Innodb cluster user too. This is the user, and this user must have all the privileges on all the databases in the server. So I'm doing that, and I'm doing the flush privileges so that the privileges gets registered in the MySQL registry. And the next step would be to install a clone plugin so that when I'm creating an Innodb cluster, the database copying from the primary to the secondaries become easy and automatic without the need to do a backup and restore command. Once I'm done with all the activities in the server, it's always a good practice to do the reset master command. And the reason for this is that the Innodb cluster uses the global transaction identifiers to identify each and every transaction that comes to the server. And this global transaction identifier is also replicated to the other two secondary servers so that all the three servers has the same and consistent GT IDs. So this I have done already all of these command in the WS2 and WS3, and now WS1 is also ready to be configured as a Innodb cluster. Now in the primary, what I'm going to do is to load some default databases so that when I am starting the when I am adding the Innodb cluster instances, that is WS2 and WS3, I have a default or few databases already pre-installed in the primary that can be easily copied onto the secondary also, and see how the clone plugin helps us do that. So now I'm going to create one of the default schema, that is the Shakila schema. And the next, I have loaded the schema. Now it's time to load the data too. Yes, right. So the Shakila database schema is already loaded. And if you see, I have the SQL scripts here. And next I'm going to load a world database. So I will run that SQL script, world.sql, and the next I'll load is the employees database. Um, the employees database is a fairly large data set, so it's going to take some time. In the meantime, I'm just going to go to WS2 and show you the MySQL instance that is pre-installed and running there, so that we are making sure that we have all the instances ready. Okay, so I'm going to show databases here. You see the default databases that is pre-installed when we install the MySQL server binary. Same test, I'll do it with the WS3 too. And once that is done, we are sure that all the three servers are ready for Innodb cluster to be configured. The GTIDs are not generated, and the bin log files are starting in the starting position. We are through there, and still the employees database is getting loaded. That's done. And let me see what is the next command that we are going to do. Now, to administer the MySQL shell or the Innodb cluster, we need the MySQL shell admin API. So I am logging into the MySQL shell using my admin user and the login credentials. So I will do that here, and my admin, my IP or the host name here is WS1 that I want to log in. I'm logged in, and I will execute this command in the MySQL shell, so that I have the capability of a kind of DOS key of the Windows feature, where when I press up arrow key, I'm able to get the previous commands that I executed in the shell. And so to begin with, when you want to create an Innodb cluster, the first step is to check whether the three MySQL instances are ready for being treated as a cluster instance. So here, when you say check instance configuration command, this is the DBA utility provided by the MySQL shell that has methods to easily work around with the Innodb cluster. Now I'm using the check instance configuration and seeing whether my server is ready for being used as a Innodb cluster, but it says that it is not, and we need to make changes to these variables so that it is configured or properly to be a Innodb cluster instance. So I'm going to do that test for all the three instances, and if you see, all the three instances has to be configured properly to make it ready. So how do we do that? It's again very simple. Just execute the dpa.configure local instance command, so that the server automatically gets configured to be Innodb cluster. So this is asking for our permission to do configuration changes in the server. We say yes, and these changes needs a server restart. So I'm going to say yes to that too. So the changes are done. Now let me do the changes for the other two servers too. Say yes to restart, and let me do it for the third server, that is WS3, and say yes and S for restart. Fine. Our server is ready, and if you go back and check the check configure instance, now you should be seeing that the server is configured properly, and you should get the status messages okay, so that we are sure that all the configuration changes has been done. Let's check for the server 3 and server 2 and check for server 3 now. Fine, perfect. All the servers are ready now, and it is time to create the Innodb cluster. I'm going to make WS1 as my primary server. So the dba.create cluster commands creates a cluster, Innodb cluster for me with the name as test cluster. I'm also giving the function, the command or the IP whitelist, so that my WS2 and WS3 are only part of the Innodb cluster, and no other IPs are allowed to be part of it. So this cluster is getting created. Yes, cluster is created. And the way to check whether the cluster is created properly, we need to get the cluster that we just created by using this command get cluster, and the simple way to find out is to find the to execute the command cluster.status and see whether our WS1 is created as a Innodb cluster, and that is in the read-write mode. Now it's time to add this two secondary instances, that is WS2 and WS3, to the Innodb cluster. I am doing that right now, and here is the clone utility that is coming into use. So what this does is, when it is adding an instance, uh, it asks whether you want to clone the data from the primary instance that you are going to be added. So I say C, and when I say clone, it connects to the primary instance, gets all the databases that we created, the world, the Shakila, and the employees, and gets copied onto the second instance, that is WS2. And it also shows the progress of the copying here. And our data set is not very huge, so the copying is quite fast, and the server is also getting restarted after copying the data, and it gives the status that the clone has finished its job, and the server is has all the data consistent to the master. Now we will add the third instance also now and do the same clone copying, and get the server completely ready for testing the Innodb cluster, right? So I will say C here, and it's going to add the instance first to the cluster, and then it's also going to ask me, copying the data from the primary, right? While that is happening, let's go back to my WS2 instance and see whether the data from the primary is copied to the WS2. Okay. So when I say show databases, I should be seeing the employees, the world, and the Sakila that is replicated from the WS1. So even in WS3, the data copying is done. And let me go to WS3 too and see whether the data is replicated or cloned rather from the primary instance. Yes, it is there. Employees, Shakila, and world is replicated. Uh, and there's another way of checking whether the instance is Innodb cluster has got all the instances attached to it by again checking the status of the server. So we will get the cluster and then check the status. So now you see that um, the WS1 is the read-write instance, and WS2 here and WS3 are the read-only instances. Fine, now the cluster is ready. The other way of checking whether the cluster is configured properly is also to go to the MySQL command client of the primary and check the performance schema, and that should have all the three servers listing for us, right? So if you notice now, I have not logged into the MySQL client of WS1 using another instance of PuTTY, but instead from the MySQL shell is providing a SQL interface too, so that I can just say /SQL and get into the MySQL command client and execute the commands that I want. So this is another feature of the MySQL shell where the need to hop in and hop out of the servers is completely avoided, and you use or create your Innodb cluster within a single MySQL or the command shell interface. Now it's time for us to install the router in our application server, that is the first one. So I'm going to log into the server and install the router and start testing the Innodb cluster failover and fault tolerance, right? Again, I will have to go back to my package folder where I have all the binaries, and I'm going to install the router there, right? Let us wait for that to get installed, and once the installation is complete, the next step um, is to go to the router folder, that is /tmp/mysql router, and start the router daemon 2. Uh, so a little bit of explanation on the bootstrap command here. Uh, right, so we copy and paste the bootstrap command, and let me briefly explain what am I doing in the bootstrap. So the bootstrap command is executed so that the primary instance gets recorded or registered with the MySQL router, and I am using a separate user for this, the MySQL router user, and I want all the router related files to be saved in the TMP MySQL router folder. And let us see what happens here. It asks for the admin uh, password. After I gave that, the router is configured to be talking to the Innodb clusters, basically the primary instance, and the router has got two ports, that is 6446 and 6447, which is the read write port and the read port to be connecting with the MySQL servers, right? That is the default port. So when from the application, if you are connecting to the MySQL server through the router, we will be essentially using these two ports for read write requests and the read requests. now it's time to start the MySQL router. This has got the startup script here. So I'm going to run that and start the router. The router is started. Just to make sure it is started, let's check with the command here and see whether the router is running. So the router is running here, and we will see what to do next. Yeah, so next is I will log into the primary instance, that is WS1, and create a sample database so that we are sure that the newly created databases are also getting replicated to the WS2 and WS3, right? Okay, so I'll say show databases again. So the new DB is not there. I'm going to create that. It's a very simple database with a table with one column. And for InnoDB cluster, it is mandatory that all the tables have should have a primary key, and I'm just going to create one additional column called name, and I will say insert into new db dot new table values. I will say reworking. Okay. Okay, let me copy this. One comma reworking. Right? Done. And I will add one more column, one more row. We are done. And we'll just say select star from new db dot new table. Okay, sorry about that. Right, and select star from. Yeah, so these two rows are there, and let us see in WS2 and WS3 too, these data are replicated. So let's log into WS2 once again and get into the MySQL server and see whether we have the databases there, the new DB database. So we see the new DB database. Okay, it's there, and say select star from new DB dot new table, and you should be able to see the two rows that we added, and same goes with WS3 too. We can now start testing the MySQL router connection from the application server, one through the Java program and other through the MySQL command client, so that we are sure that we are connecting to the right ports. That is, I'm using the MySQL client utility here to, and then instead of using the default port of 3306, I'm using the 6446, that is the router port, to connect to my primary instance, that is WS1, and to check if I'm able to connect to the read ports also, I change the port here and see that now I'm connecting to the WS2, and if I execute once again, I'm connecting to the WS3. So randomly the read ports are picked up by the router for catering to client requests, right? Now, the other way to test whether the router is working properly and connecting to the right MySQL server, I have got two Java programs that is already pre-configured in the fourth application server instance. And let me show you the Java program. It's a very simple Java program that uses the MySQL connector, Java connector, and in the connection parameter, I am giving the MySQL router port 6446 port, and I am not directly connecting the MySQL server using the 3306 port. And what this program does is just connect to the primary server, and I'm selecting the host name so that we can test whether we are connecting to the right host from a Java application too. And for retest, I'm using the 6447 port, right? So let me copy the command that is to run the Java program. Uh, so I will first run the failover test just to check whether we are able to connect to the MySQL server using the router to the 6446 port. So I need to go to my folder where I have the Java programs, that is home OPC, and my Java is the folder where I have the Java programs already configured. Already compiled with in order to have a class file, so that Java class file, so that I can run this command. So here I'm running the Java program, and the Java apparently needs a MySQL connector, the Java connector, which is I already pre-installed in this server. The connector is, you can download it from the MySQL download site, and install it like just any RPM installation using the rpm-ivh command. So now what you see here, the output is I am connecting to the WS1 port because WS1 server, because this is my failover test using the 6446 port, right? So that is one way of testing, and I'm going to stop that. And now let us also test the read port, that is 6447, using the other Java program, right? Okay. So now if you see, I'm connecting to the WS2 server with the 6447 port that is given in the connection parameter. And if I run the same Java program again, I should be able to connect to the WS3 port, right? So the basic testing of checking the right port, the read port, and the read write port from the Java program is done, and now it's time for us to check the failover utility of the Innodb cluster. So what I'm going to do is to go to my WS1 instance and shut down the WS1 instance, the MySQL running there, and then go to my WS2 instance also and check from the MySQL shell utility as to what is happening in the server when one, in the Innodb cluster, when one server is shut down, right? Okay, now I will say system control stop MySQL D to stop the MySQL daemon or the MySQL thread, and that is stopped, and I will log into my MySQL shell. Now that the WS1 is not there, I am going to connect to my WS2 instance and check the cluster status. WS2 is connected, and I'm going to get the cluster and check the status now. Cluster dot status. So if you see here, the WS1 would have gone because I have shut it down, and the status goes missing here, and WS3 has got itself promoted to be the new read write or the new primary master, and WS2 becoming the read only server. And now the cluster has only 2 instances instead of 3, but due to the automatic failover, the cluster is still available and up and running. So that is the cluster status for us. The next thing would be to now WS2 is being the new primary, WS3 is being the new primary. I'm going to go and shut down WS3 to this MySQL daemon and go back and check the status of the cluster, right? So let me go and shut down the MySQL daemon in WS3. It is shutting down, and I want to go back to my shell and see what is happening to the cluster, right? So if you see here, now WS3 is down and it is no longer the primary read write. Instead, WS2 has got itself promoted to be the next read write. And now I'm going to go back and start both WS1 and WS3, right? That is started, and open the MySQL shell once again, and we can connect to any of the servers, WS2, and get the cluster and check the status. Now all the servers should be um, online, and WS2 is the read write, and WS1 and WS3 has become the read only server. So you must have noticed, even after restarting WS1 and WS3, the cluster has not made those two as the read write, because to maintain consistency, WS2 is already the read write and that consistency is maintained, and WS1 and 3 become the read only instances. Right now, we will test the failover from the Java application too and see what it shows us. Right, go back and open the instance once again. I will go to my folder where my Java program is there and start running the Java program once again. Okay, I don't seem to have that here, so let me copy and paste from our notepad. So now you see, since WS2 is my read write port or the read write instance, now the output is showing me WS2 that is getting connected through the router port 6446. And let us check for the read to using the router read test program and see what is the output that we are getting. So now the WS1 is a read-only instance. So this Java program is connecting to the WS1 and showing us the server host name as WS1. And now it should be showing it as WS3. Um, this ends the installation and configuration of the MySQL Innodb cluster. Hope you enjoyed watching the video, and let me know if this is useful to you. And thanks once again for watching, and have a pleasant and wonderful day.